Red dwarf. Red dwarfs are the most common type of stars in the universe, even though they are small and faint. They burn their fuel very slowly, which allows them to live for trillions of years, far longer than stars like our sun. Because of their low brightness, they are difficult to see from Earth without telescopes, but they make up the majority of stars in our galaxy. Yellow dwarf. Yellow dwarfs are medium-sized stars like the sun, providing a stable and steady source of light and heat. They burn hydrogen at a balanced rate, which gives them a lifespan of around 10 billion years. These stars are especially important because they often support planetary systems where life could potentially exist. Blue giant. Blue giants are very hot and extremely bright stars that burn their fuel at a rapid pace. Their blue color comes from their high surface temperature, which can be several times hotter than that of the sun. Because they use up energy so quickly, they have much shorter lifespans, often lasting only millions of years. Red giant. Red giants form when stars like the sun run out of hydrogen in their core and begin to expand. As they grow larger, their outer layers cool down, giving them a reddish appearance. Despite being cooler on the surface, they are much larger and brighter than they were in their earlier stages. White dwarf. White dwarfs are the leftover cores of stars that have completed their life cycle. After shedding their outer layers, what remains is a dense, hot core that slowly cools over time. These stars no longer produce energy through fusion, but they still glow due to the heat stored within them. Neutron star. Neutron stars are incredibly dense objects formed after a massive star collapses in a supernova explosion. They pack more mass than the sun into a space only a few kilometers wide, making them one of the densest forms of matter in the universe. Their strong gravity and rapid rotation can create powerful beams of radiation. Supergiant. Supergiants are among the largest stars in the universe, with sizes that can be hundreds or even thousands of times larger than the sun. They are extremely bright and live very short lives due to their high energy output. These stars often end their lives in dramatic supernova explosions. Protostar. Protostars are the earliest stage in a star's life, forming from collapsing clouds of gas and dust. At this stage, nuclear fusion has not yet begun, but the object is heating up as gravity pulls material inward. Over time, if enough mass gathers, the protostar will ignite and become a true star. Binary star. Binary stars are systems where two stars orbit around a common center of mass. They can vary widely in size and brightness, and their interactions can affect how they evolve over time. Studying binary systems helps scientists understand how stars influence each other through gravity. Variable star. Variable stars are stars whose brightness changes over time. This can happen due to internal processes, such as expansion and contraction, or external factors like eclipses in binary systems. These variations provide important clues about the structure and behavior of stars. Pulsar. Pulsars are a special type of neutron star that emit beams of radiation from their poles. As they spin rapidly, these beams sweep across space like a lighthouse, creating regular pulses when observed from Earth. Their precise timing makes them useful tools for studying space and testing physical theories. Brown dwarf. Brown dwarfs are objects that fall between the largest planets and the smallest stars. They do not have enough mass to sustain full hydrogen fusion like true stars, but they can still produce some heat and light. Because of this, they are often referred to as failed stars, existing in a unique space between planets and stars.